I'm sure that you know about charging and discharging of mobiles. And you must have seen lightning in the sky during thunderstorm. What are these? These are the natural phenomena that comes under the branch of physics which is called electrostatics. Electrostatics deals with the study of forces, fields and potentials arising from static charge or the charges at rest. In chapter 1, that is electric charges and fields, you will study about forces and fields due to electric charge. And in chapter 2, that is electrostatic potential and capacitance, we will study potentials due to electric charge. And in short, I can say that the chapter 1 and 2 of your NCERT book is all about electrostatics. Let's focus on the charge. In 600 BC, it was first observed by Thales. He was a Greek philosopher, and he observed that amber, when rubbed with silk or wool cloth, attracts light objects such as feathers and straws. Amber is made up of sticky liquid coming out of the trees. When these sticky liquid dries up and it goes under a huge compression process under the earth, in millions of years it turns into a very hard and shiny stone. That is amber that you can see on the screen. For many years, people did not know why it happens, why the objects get charged. But they tried it on different objects and they found some patterns. Okay, they just found that there are certain pairs of substances or objects, and when they are rubbed together, they get that magical power which can attract other objects. Electron means amber in Greek language, and it is the root word for many words such as electrostatics, electric, electromagnetism, electron of an atom, etc. Let's see the list what other people tried at the combination of substances to get this kind of property. So the first one is when fur is rubbed with amber. Fur gets positively charged and amber gets, or hard rubber gets, negatively charged. Glass becomes positively charged, silk or wool cloth becomes negatively charged. Hair is positively charged, and when we rub the comb in our hair, the comb gets negative charge. The term positive and negative was given by an American scientist, Benjamin Franklin. And this development is recent. For many decades and many centuries, people just tried a pair of objects or, combination of objects to see that they get similar kind of properties in the matter or not. And today we can say very confidently that when two glass rods are rubbed with silk or wool cloth, they get charged. Since they get similar kind of charge on each other, okay, so what happens when they are brought close, they repel each other, what you can see in the picture. And when rubbed glass rod and amber is brought together, they have attractive forces working between them. They are attracted to each other. And from this we can say that like charges repel and unlike charges attract. And these very properties are called polarity of charges. Also, it was found that there are only two kinds of charges. One that is on the glass rod and the other that is on the silk or the wool cloth. And we can replace these pair of substances by any pair, and we get only two kinds of charges on any pair of substances rubbed to find charge. Let's revisit the image of this experiment. In this experiment, there are two glass rods. One is handheld and one is hanging with the help of a silk thread. When these glass rods are rubbed with wool or silk cloth, they get charged. And when they are brought near, they can experience repulsive force. This is possible because both the glass rods are charged and the charges are of the similar nature, similar kind of charge on these glass rods, and these are positive charges. To preserve the charge in the glass rod, silk thread is used. Silk thread actually behaves like an insulator that we will study in some time. So insulators never let the charge go through it or pass through it. Let us learn about the reason behind this generation of charge. Let us start with bulk matter. So any substance which is good enough in size and good enough in mass is called bulk matter. If we ignore atomic and subatomic particles, okay, then if we ignore these two, and rest of the things can be considered as bulk matters. Modern view says that bulk matter is neutral in nature. What does that mean? Bulk matter is neutral simply means the number of positive charges and the negative charges, or the amount of positive charges and the negative charges on any substance, any bulk matter, are equal. Based on the fact that amount of positive and negative charges are same in any substance, we can say there is no effective charge on any substance, any bulk matter. Alright. And that's what makes the bulk matter neutral. So no effective charge. But when these matters are rubbed, for example, glass rod is rubbed with the woolen or the silk cloth, some amount of charge is transferred from one substance to the other, and it upsets the electric neutrality of both the materials, and in this case glass rod becomes positively charged and the wool or the silk become negatively charged. Question still arises, what kind of charge is transferred? Positive charge is transferred or negative charge is transferred? To understand this, let us see what happens inside an atom. Inside an atom, there is a very compact nucleus. And inside the nucleus, there are two subatomic particles. One is protons and the other one is neutrons. And the electrons revolves around the nucleus. Now, protons are positively charged. That's why the whole nucleus is positively charged. And the neutrons has no charge on it. Electrons are negatively charged. Protons are packed inside the nucleus with a very strong bond that is called the nuclear bond. And it will never leave the nucleus. But electrons are loosely attached to the nucleus or to the atom as compared to the protons. Because of this loose attachment, electrons can easily be detached and can be spread on the surface of any body. And when two bodies are rubbed with each other, the negative charge or the electron is get transferred because it is loosely attached to the nucleus or to the atom, or for that reason to the substance. And we can say that any electrostatic phenomena is just because of the transfer of electrons. Well, to sum up this, what happens inside? It is the transfer of electron or the transfer of negative charge. The charge on an electron is given by small letter e, and the value of this charge is 1.6 into 10 to the power minus 19 Coulomb, and Coulomb is the unit of the charge. The symbol for Coulomb is C, capital C. On electron, the charge is negative, so we can say it is minus 1.6 into 10 to the power minus 19 Coulomb. And on a proton, the charge is equal in magnitude. It is just the positive charge, so it is 1.6 into 10 to the power minus 19 Coulomb, and that is the charge on the proton. Let us define Coulomb. A Coulomb is defined as the amount of charge that flows through a given cross section of a wire in 1 second if there is a steady current of 1 ampere in the wire. The definition says that in a metallic wire, if 1 ampere of current is maintained, then Coulomb is that amount of charge that flows through the cross-section area of the wire in 1 second. And what is cross-section area? When you cut a wire, just cut a wire from anywhere, and the area you see then is the cross-section area. So the amount of charge passing through this area in 1 second is Coulomb when the current is 1 ampere. And the formula for this is given as Q is equal to I multiplied by T, where I is current, Q is charge, and T is the time. Well, I don't expect that you go through this result right now. We will wait till we reach the third chapter, that is the current electricity. So we have to wait for that. For now, just to define Coulomb, we need to take the help of current. That's why I have mentioned current here. Otherwise, we really don't need that here. So just go through the definition. That is more than enough for now. While defining Coulomb, we talked about the amount of charge. And that's why it is important to see this instrument, which is called the gold leaf electroscope, through which we can measure the amount of charge. It was invented by Abraham Bennett in 1787. Gold leaf electroscope is a very simple instrument. Inside a glass jar or glass bottle, we insert a metallic rod, and on one tip there is a strip of gold that is bent to form gold leaves. We choose only glass jar and not any other metallic jar is just because glass jar is insulator and we are dealing with charges, so it is shock proof. And the other thing is glass jar is transparent, so we can see what is going on inside. On the top of this instrument there is a brass disc, and when any charged metal is touched to this brass disc, the charges flow inside and it comes to the gold leaves, and the charges are equally distributed in both the leaves, and because of the equal kind of charge, the leaves get deflected, and the angle of deflection gives the strength of the charge. So more deflection means huge amount of charge or higher amount of charge, and less deflection means less amount of charge. Let us learn about conductors and insulators. Those substances which allow electricity to pass through them are called conductors, such as metals, human and animal bodies, and the earth. Okay, we also talked about that when any substance is charged, it is just the transfer of negative charge. Alright? This can be verified by the experiment called the Hall effect. But to grasp the concept of Hall effect, you should be knowing electric current and the magnetic field. So we have to wait till we reach these topics. Okay? For now, just understand that to create charge, there is always transfer of negative charge. And this can be experimentally proven by the concept called the Hall effect. It is given by a scientist with the name Hall. Then there are substances which don't allow to pass electricity through them, and they are called insulators or the dielectrics. For example, glass rod is an insulator, and for the same reason we can say rubber, plastic, fur, silk, wool, and mostly the non-metals are insulators. Materials are broadly classified as conductors and insulators. But then there is one third category of materials. They are called semiconductors. Semiconductors are intermediary between conductors and insulators. They are not a very good conductor and not a very good insulator. But when some impurity is added to the semiconductors, their conduction ability enhances drastically. For example, silicon is one semiconductor, and when we add some arsenic to it, the conduction of silicon is enhanced many folds. That is why semiconductors have many practical applications. But we will stop here with the semiconductors because we have one full-fledged chapter in our book on semiconductors, and we will study the whole part in that chapter.